Good to see so many of you survived the party last night. Hi. So, welcome to this first session for the last day. It's on IoT, big data, cloud stuff. My name is Thomas. I have a degree in business economics, but I've been a developer for most of my professional life. Currently, I'm working as a developer mainly on ERP applications. So I know a thing or two about SQL Server. That's what started me, and as a speaker, I've been to quite some SQL Server conferences, and lately I enjoyed the developer conference as well, and that's why I'm here. Right, our topic for today, what will it be? Well, first of all, a little intro what I think IoT is or should be, and then it'll be about the Arduino ecosystem, okay? Which consists of hardware, I got some here with me, the software and the cloud solution. And because I'm sort of a Microsoft data person, I'll also hook it up to the Microsoft Azure cloud, which has quite some possibilities. At the end, I'll share some resources, some links with you if you want to dig in deeper. I will see how that goes. Oh, by the way, any of you have already experience with Arduinos? One and a half, two. Okay. So, first of all, the IoT, the so-called Internet of Things, what does that mean? So it's all the devices or things that are connected to a network, or maybe they're not, we'll see. And they may be equipped with some additional things, like sensors. What's a sensor? Well, a sensor takes some environmental measure and puts it into an electric signal. So you can have all sorts of sensors like temperature, for humidity, for air pressure, for like, you name it, you've got it. They can be connected to those devices. On the other hand, we have the actuators that take an electric signal and put out something to the environment, like light, an LED. You put a voltage on it, it emits light, or buzzers for sound, or motors for motion, that sort of stuff. Then usually those things have a processing capability, like there's a CPU on it, okay? And there's a big trade-off between the use case requirements, the cost of that particular module, and of course the power consumption. Think of it, if you want to put an IoT device somewhere in the field where there's no electric grid, you have to run it on a battery, probably, or on solar power. But you don't want to drive out every week and change the battery. So you have to think about a CPU that's low on power consumption, for example. And yeah, maybe or maybe not the means of communication. So if you go for IoT as really the Internet of Things, it has to have some sort of connection. That can be Bluetooth or Wi-Fi or one of the other things, cable Ethernet or even satellite connection. I would take a broader approach as saying, if you have a device and put it in the field where it does not need any connection, I still call it an IoT device, okay? Some examples. Who knows what the first ever known IoT device was? Any guess? It was a code vending machine at Carnegie Mellon in 1982. So there was, on one end of the campus, there was a Coke machine, and the students from the other end, they had to walk there and find out, oh, my favorite Coke slot is empty. Boo. So they put in some sensors, attach some sort of computer, attach it to their local network because there was no internet yet. And they could go from any terminal on the campus, put in a certain command, and it would come back with the how many Coke is in there. Okay? So maybe you heard about the coffee machine cam. That was probably the first webcam ever, but that was 10 years later. It was on the internet. You could, from anywhere in the internet, you could look what the coffee was like in the University of Cambridge. Well, so any remote webcam is an IoT device. Today, you can, at any place in the world, you open a browser and you can look what, like, I don't know, Times Square, New York is looking at that moment, okay? Home automation, stuff like that. Your mobile smartphone, it has an awful lot of devices in it. And it has Bluetooth, it has Wi-Fi, it has mobile connection. I mean, who of you does not own a smartphone? Yeah, there you go. Right? Everyone carries their personal IoT. Yeah, wearables like smart watches and all that stuff. Smart vehicles, we know about them. And then, my favorite, your smart fridge, which orders the milk for you when it's empty. I mean, that was the hype when IoT came out. So who of you actually owns one of those fridges that orders the milk by itself? No one. And I know no one else who does. I don't know what became of these things. Okay, and then there's, of course, I would almost estimate millions of Arduino-compatible units out there that are regarded IoT devices. Okay, Arduino. What does it mean? Arduino, the name. It stands for. There's a company in Italy which came out of a student tool project almost 20 years ago, and there's been some back and forth legal blah, 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 blah. But today it's the Arduino company in Italy, and they produce called it original Arduino hardware. So if it says Arduino on the board, it's from them. It is open source, also the hardware, so anyone can build a compatible board and not call it Arduino, but it may look almost the same. I've got one here later. And they have different families of models. We show that later. And they have a software developing environment, an IDE, specially built to produce software for those Arduinos. It runs on the major operating systems, even as a web editor. And there are like 7,000 libraries that you can use officially or from someone else. Like, I'm an application developer. If I connect a sensor to my unit, I don't want to poke around the bytes and look what the signal looks like. I want to say, give me the temperature. Zuck. So I need a library for that. Yeah, and there's a maker community. They run online forums, they run user groups, they run events and other stuff like that. Hardware. So in the stricter sense, Arduino company produces hardware. Hope that works. Just for some examples. Now let me see. I'm going to show you just some of them. So that was, no, that's not the one. That was the standard top model until last year. Yeah, it's the Arduino Uno. It's R3, so it's revision 3 or model generation 3, whatever you want. And you see the CPU is on a socket here. So you can tell it's probably not very fast, right? And if you look here, it has a USB connector, but that is a USB-B. So that made me dig out my old USB-B cables, which I have thrown away already, to get that thing connected to my computer again. I go into the details in a moment. I'll just show you the current top model. So that's revision 4, that's the next generation. It's a bit tidier. It has a mounted CPU instead of a socketed one, and it actually has USB-C now. Okay? But that one doesn't have any radio. No Bluetooth, no Wi-Fi, just like that. And then you got the Wi-Fi model. That's a bit more sophisticated. And you see here on the left, that's the Wi-Fi module. And very characteristically, the zigzag here, that's the antenna for it. And that one's got a lot of other connectors here and a beautiful matrix of LEDs, which you can address individually. Okay. Let's see. Oh, yeah. The pin rows are in a very specific way, and that is because you can, let me see. What have we now here? You can put other boards on top of that, so-called shields, if you need additional functionality like this. So you see it has the same pin rows as the basic CPU ports. You can just plug it on top. And for example, this one brings a cable Ethernet connection and a SD card slot and a couple of other connectors. So you can stack them on top of each other. I've seen like 5 on top of each other with different functionality. Expandable at its best. Okay? Right. Then the wiki has a list of Arduino board and compatibles. There are like hundreds of them. I'm not going to go into that detail. So if you're interested, you can scroll through them and see what is up there. So we got, yeah, you can get them in shapes like that one is already in a case. It has a small display on it, fully integrated for about $20. So the most basic boards probably come for around like 10 euros. And it goes all the way up, of course. More features, more bugs. Yeah, they come in really small sizes. I don't know which one you can see it. That one. If you imagine that up there, that's a USB connector. So you might imagine how big that actually is. And that's a full-fledged Arduino. There's a CPU on it and everything. Yeah, they come in funny shapes. I got a round one around here. I'm going to show you that actually later. And already like Raspberry, you know Raspberry Pi. Raspberry also does a series that's called the Pico family that is Arduino compatible. Okay, so that one, I've got it here. It's about that, whoa, that size. Yeah, it fits into your hand. That's a compatible Uno R3. It has the socketed CPU, it has the USB connector. Down there you got an additional power up because if you want to, as I said, I put it somewhere in the fields, you hook it up to a battery power, not the USB. And it has several connectors, it has a couple of LEDs, like one is up there, can you see that? That is addressable, it has a power LED and stuff. So. And it has the characteristic rows of pins, like down here is for all the voltage. Bottom right is some analog input pins, and on the top, the whole row is for digital in and output. And some of them have several functions. And it has also some special connectors for defined other interfaces, let me put it that way. Okay. Then the software. As I said, there is an IDE which runs on the major operating system, which looks like this. Is that okay for you to see in the back? I'll put it a bit bigger. So it's nothing very fancy. On the left, you got like a file explorer. You got the boards manager because you need to say which board are you going to use. Like this is an Uno, so somewhere it should say Uno board or something like that. That's the library manager. As I said, for different purposes, you need libraries that address your sensors and so on. Sometimes you have the property of debugging. Not every board makes that possible, sadly. You can search around, blah, blah, blah. So, and on the right here is the program. So when you start a new programming language, what's usually the first program you build ever? Come on. Hello World, right. So that thing doesn't have any monitor, any display. So what good is a Hello World program? It isn't. In the Arduino world, instead, you have the Blink sketch. So an Arduino program is called a sketch. And when you start, you get to do the Blink sketch. I'm just hooking it up now. Let's see. And it starts talking to me. Basically, yeah, the language is like C or C#. Okay, so we got always those two functions, the setup and the loop. If you're looking for a main function, there isn't. It's under the hood. So the IDE of the Arduino takes care to transfer that to a main function and then stuff with whatever you need. So why is this running here? Okay. You always have a setup function that is run once at startup or at reset or when you plug it in. And then there's the loop function, and the loop function does exactly that. It runs in an endless loop after the setup is done. Okay? Then we got a thing called the serial. That's when you plug it into a computer and you see down here the serial monitor. It can send data to the monitor, to the computer. That's not strictly necessary, but I put this up here, and oopsie. And it tells me what my program is actually called, because we got a dozen of those things lying in your drawer. You can't see from the outside which program is on it, right? So I always do that in my programs in the setup, and when I start it up, down there you could see it says, hey, I'm the Demo 1 Blink program. So I know, that was the Blink. And it says when it was compiled. And then basically what the Blink does is there's a port or a pin defined as the built-in LED. That's number 13. And I say I want to use it as an output. I might use the pin as an input. I have to specify that for every pin I use to connect some peripheral. And that's all for the setup. And then the loop starts running. And the loop, what it basically does is digital write. It writes to the defined LED pin. And I switch between high and low. So that with high, you give a voltage onto the pin. With low, you set it to 0. And because the LED is attached to it, it goes on and off. And then you got a delay here, which really delays the system. So it's not very sophisticated programming. While the delay is running, nothing else can happen. So maybe you would use an interrupt for that or something once you get to it. And there's a delay here, and at the serial, I printed out on the serial what it does. And yeah, that's what it does, nothing more, nothing less, does it? Yeah. Up there, that's the power LED, and if you look down here, the yellow one, it's blinking on and off. Nothing too fancy, but yeah, instead of the hello world, we use that. Okay, I'm going to plug this out so it doesn't interfere. Okay, so that was simple. Next up, yeah, Arduino has a cloud offering, and you can register and have a free plan to use it. You can also have paid plans with more features, of course. For the moment, I stayed with a free plan because at the beginning I said I'm an ERP developer, so you might ask yourself, what has that got to do with ERP developing? Nothing. So it was like, I was looking for a sidekick or a hobby. So about a year ago, I started with that stuff, and I didn't want to invest too much money. I got some hardware, but I didn't feel like paying money for the cloud when I can have little examples running there. So, yeah, the cable is a bit short. I got this one here in a little 3D printed case. What you see here is a round computer board. It has a CPU somewhere on it. It has the USB connector. In that case, it's only for the voltage, because the programming happens via those yellow pins. Somewhere on it, there's a temperature sensor. I'm not quite sure which one it is. And that characteristic dome up here is an air quality sensor. So it looks for certain particles in the air, like you could call it a gas sensor. You can get several information out of it, or one value that says, your air quality is good or not. Okay. And then I went and hooked that up to the Arduino cloud. Arduino cloud, which looks like this. So you have to register, but as I said, you can use a free plan. It doesn't cost you anything. And with Arduino, what you do in the cloud, it's not called an app, it's called a thing. So, yeah, the Internet of Things. And within a thing, let me see, you got two things running here. You just define, I have some variables, however they are generated. There's my Wi-Fi credentials. And you can build a sketch from within the cloud and load it down onto the device and then have it running. For things, you attach devices. So that's the actually board, that's called a device. And you see it's online and it can, yeah. You see down here on the left, it says, yeah, it's sending data to my Envoy thing. Envoy is just because the board has that name. And it has some additional data, and you see the device history. So I played around with it like yesterday to test it before and so on. And what it does, it sends data, and I produce a dashboard. And there you go. So, okay, on that screen, some frames are missing around here, but you get the picture. You can have like simple numbers, you can have like gauges, and you can have like timelines. It says the temperature is 32 degrees, which is not. That little gas sensor has to be heated in order to work properly. And the temperature sensor is somewhere near it. So it gets some of the heat and the temperature's wrong. So it's a hobby device. But the tendency is there, so if the temperature rises, that will rise also. The humidity here up front is like 25%, and the air quality is not the best. There's an arbitrary value. The lower it is, the better the air quality is. And there's an indicator there. I programmed them to be red when it goes up more than 300. So at the moment, I'm trying to put some air here. Well, at the moment, it's higher than 300, so it says red. Oh, careful about your air quality. Open the window, have some fresh air, whatever. Okay? Simple as that. Yeah. Then, yeah, you can have some triggers whenever I didn't go that far. You need to upgrade it. You can use templates here. From here, you can jump to courses to learn more about the Arduino stuff and how it works. You can have integrations to other software appliances via webhooks and so on. Quite nice. Okay, so with the free plan, you can have two things at any given time. You can have several devices connected to those things, but only two things. You can have dashboards as much as you like. You can have a bit of store for your sketches, even ML tools. I didn't try that, but you have only 1 day of data retention. So if you push up data every day, yeah, if you look the day after tomorrow, the rest is gone. It's for the hobbyist, right? Okay, so we're all ready for the next one. Let me just check my hotspot here. Is it working? No. Where is it? No. So I have it here. It's about that size also, and I have hooked it up to a power bank. It runs without connection to the PC because I have it connected to the hotspot in my mobile. And what we've got here is a more sophisticated board, which has a so-called ESP32 processor, which has more power and more RAM and more flash memory and all that sort of stuff. The blue thing up there is a temperature and humidity sensor, and the green thing is an LED. By the way, when trying to set this up, I fried one of the sensors because the pins are not marked like they are here in the schema. So I connected it wrong, and then after that it was gone. Okay. And then I hooked that up to the Microsoft Cloud. So there's different IoT offerings in the Microsoft Clouds. There's the IoT Hub. There's some other stuff that attaches to that. This is the IoT Central, which I thought was easier to set up. And also there's the possibility to use it free, let's put it that way. Yeah, this is the welcome screen. It tells you how to go about. It also has some templates you can use and create an app from there. So what in Arduino world is called a thing, here it's called an app. You have to have a name for your stuff. Okay, so I put up 2 apps, and yeah, you see I've got a Google phone here. You can have a readily made app and then have your phone send data to the cloud, just like that. You put an app on your phone, and whenever you open it, it sends all that sensor data, and you can build a dashboard around it. So I tried that one out. But here I got an app for the ESP that I have here on my board. So let me see, where do we start? Probably with the templates. In the IoT Central, you start with a template, and with a template you define, just like we saw before, what kind of data my devices are going to send. So I have a temperature, another temperature, I have a humidity, and there I got a command which says toggle LED. So we see how that works. And the device itself can have properties that will be sent, so you can see it's the correct device to attach to. Then from the templates you can define groups of devices. And within that you have the specific devices. I have one here, which is called the ESP32Dev, and it's green, so it's connected. And we can see that it sends data, actually, like every 10 seconds. It sends a humidity, it sends a temperature. Yeah, well, 24, that may be the case up front here. And the temperature in Fahrenheit for the UK and the US folks. And if you click on here, you will see that's simply, yeah, it's a bit small, but that's a JSON data package that gets sent. Because under the hood, it uses the MQTT protocol, and I think that works mostly with JSON. Okay, so the data arrives here in the cloud. What can we do with it? Yeah, there's Data Explorer. That is more, oh yeah, you see. On the left, that was my try like yesterday, and that was the night, and I just switched it on like this morning, and you see where it goes on. The Data Explorer is more, and you see it up top here, if you have several groups of devices, like putting sensors on every floor of the building, or like all over the country. So you can compare the groups, like how are the northern sensors doing in regard to the southern ones or whatever. So for a single one, it doesn't make much sense here. But you can also here have a dashboard. Yeah, I kept it simple like that. And you can see on the bottom is the humidity, how it develops, and on the top it's the temperature. But that's not all, of course. You can have jobs running here regularly to do something with your data. You can have certain rules, like whatever. If the temperature rises above 40 degrees, or send a signal to get the animals in, or whatever. Huh? Or if, I don't know what, if in the garden humidity is like more than 100%, it's probably raining as hell, so do something. And what you can do, you can export data to several destinations. I tried this one only recently, so that's probably stuff for another session. With this, I exported to Azure Blob Storage, which worked quite nicely from the start. You just set it up, and it goes there, and yeah, and sends you a bill at the end of the month, because Blob Storage is not for free. Yeah, but that was like €1 for a month or so. Yeah, and the other thing I tried was going to Azure Data Explorer and Custo and KQL database stuff. That did not yet work, so I disabled that again. And of course, you can go on and customize your application. Simple as that. So let me just see. We had one thing I wanted to show. That was the commands. Yep. So I have this yellow LED on here, and I defined a command which says toggle LED. So if I go here in the cloud environment and push that button, which runs the toggle LED command, no, it takes a second or 5. No. What about the Wi-Fi here? Come on, demo gods, be with me. Ah! So, it toggles the LED on and off. Put it again. I don't know why it's that slow here. Maybe puts the LED off again. So it's only to show it's not a one-way street there. Yeah, with the IoT Central, you can get data into the cloud, but you can also do stuff from the cloud onto your devices. You could, like, this was a simple example of switching an LED on or off, but you can also push data to the device in order to modify its behavior. Yeah? So, okay. Yeah, there's a price for everything, also for the IoT Central stuff, but the pricing includes 2 free devices. Now you have to pay attention. With the Arduino, it was 2 things, and you could have several devices. In the IoT Central, it's 2 free devices, not apps. And then you can go like, yeah, I think there was a standard 0, 1, 2. 2 was the top one, which is usually the most expensive. But if you keep it to 2 devices, also that one is free. So I said, yeah, I can take the top plan and stay within 2 devices, and I'm still off without any cost. But that may change, so be aware and if you want to try it out, go to the Microsoft pages. And then you create an app and templates, and as we saw, do lots of funny stuff like dashboards and exporting data. Okay, so we're almost done. I've got some resources here that led me up to this session, and there's one, let me see, I want to show you. That is the Microsoft templates side, let me put it that way. And you have several templates for IoT Central as well as for the IoT Hub. And I used this one here. It has a template for the ESP32. And it also, it takes you through all the steps you need to get it hooked up here. But beware that the screenshots may not be the current ones. So if the menu items may have different names. I think there was someplace else, so you have to look out a little bit for that. And then here on the left, you have all the source files you need, actually, to get that up and running. So what I did was just I downloaded the source files from here and modified them. And that looks like this in my environment. You can already see that there's quite some files in here. Let me see. What do I need? Toggle stuff. Yeah. And I went in and I defined my variables here that I want to use, like the temperature and the humidity, and I defined the action that would be toggle LED, and so I had to implement it here. As an addition to the template, like here, when it says the command toggle LED, it either puts it on high or low, alternatively. And also you have to go and show it to you. You have to go and define how your data is produced, like in this one. The DHT is the name of the sensor and of the sensor object that I created, and that gives temperature and humidity. As I said, there's a library for that, so you don't have to poke around byte-wise or something like that. And then you just get your data into some variables and then integrate them into the building of the payload that goes to the MQTT, right? So usually I would share my source code, but in that case it doesn't make much sense because it depends on what you have, what kind of sensor, what kind of board, and how you go about to connect it to the internet. But you can always download that example if you want to get started with Microsoft Cloud, modify it to your needs, and then you're up and running. All right. Then, yeah, if you want to get started with it, there are courses from Arduino themselves. You can probably have them for free. The Class Central, I think, is more of a meta page. It shows you where the places are that have courses. The other one may be paid or may not. There's Microsoft Learning on Azure IoT Central, like what I use, or IoT in general. And I mean, usually I like to bash on Microsoft for their like VS Code. It really sucks. But the learning page is really good. I mean, earlier we had like books online for SQL Server. That was no good. It had errors and you wouldn't go about. But the learning pages, they are really good. They are mostly on the current, what is in the product. And I really like to go there to get my brain started. Yeah, and of course you can search for Arduino, blah, whatever, on the internet. Okay. With that, I'm done. If you like, you can download the slides from that address or give the QR code a shot. It has all the links clickable. There's my social media. I'm still on Twitter. I still call it Twitter even for the time being, but maybe I'll be in Blue Sky a bit more. I also have a LinkedIn account. Yeah, and with that I'm done. I hope I pronounce it la by a shoe for your time and interest, and enjoy the rest of the conference.